NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new.
When you really think about someone saying, let's invent a telescope that can see,
I don't think it is very useful to speculate on what God might or might not be able to do.
The James Webb Telescope just discovered rogue planets that shouldn't even exist, let alone drift together in pairs across space. Planets with no star to orbit, wandering in the dark, untethered and breaking every rule we thought we knew. But even more strange, they move in pairs, defying all logic and leaving scientists baffled. These gas giants drifting aimlessly through the Orion Nebula could be rewriting everything we know about how planetary systems form. Tune in and brace yourself for a revelation that could tear apart the very fabric of the universe. JWST shatters cosmic expectations. The James Webb Telescope has a pretty amazing infrared camera that lets it see the farthest reaches of space. It's been searching for the oldest and most distant cosmic structures, and it turns out that things are getting weird. We've spotted galaxies that seem to have popped up just a few 100 million years after the Big Bang, fully formed and as large as our own Milky Way. That's not supposed to happen. Our models can't explain it, and that's just the beginning of the chaos. But what the telescope saw next has left scientists questioning everything we thought we knew about the early universe. And then there's something even more bizarre: rogue planets. Normally, planets belong to a star, like Earth orbits our sun. But it seems there are planets out there that just aren't interested in this whole orbit around a star thing. They're called rogue planets, and they just drift through space, unattached, like cosmic loners. Some got kicked out of their solar systems, while others may have never had a star at all. They formed on their own, out of gas clouds, a little like stars do, except they're too small to actually become stars. What's going on here? Why are these loner planets suddenly showing up in twos? It's still a mystery, and astronomers have a couple of ideas, but they're not really sure. One thought is that maybe these planets formed in a part of the Orion Nebula that just didn't have enough gas to make proper stars. Instead, they got these gas giants, which were then left to float away. Another idea is that they were part of regular solar systems, but something, maybe a massive cosmic event, kicked them out, and for some reason, they got kicked out in pairs. None of these theories really explain why the planets always seem to come in pairs, though. It's almost like there's a pattern, but we don't understand what's causing it. Some scientists think that maybe our models for how planets form and evolve are just wrong, or at least incomplete. The Orion Nebula could be running on a system that we don't understand yet. Maybe it's a kind of factory that makes pairs of gas giants instead of stars. We might be looking at some kind of rule that's been hiding in plain sight this whole time, but until we know more, it's all just guesswork. The question on every cosmologist's mind is, how did these galaxies manage this kind of rapid development? Was there a process that allowed gas and dust to collapse and form stars more quickly in those early epochs? Did some kind of accelerated star formation mechanism operate back then that we don't see in the present universe? These are questions that can reshape our understanding of cosmic timelines and the speed at which the universe became filled with light. One proposed idea is that these supermassive black holes grew through direct collapse, where huge amounts of gas condensed under their own gravity without first forming stars. This would have allowed them to amass incredible size in a very short amount of time, but even this theory doesn't fully account for the extreme growth rates that JWST is observing. Some researchers even suggest that there may have been pathways to black hole formation in the early universe that we've never seen or considered. The Hubble tension suggests there's something off in our basic cosmological models. The simplest explanation is that there might be some kind of unknown force or energy influencing how galaxies and clusters move through space. Some theories point to dark energy, an unseen force thought to be responsible for the accelerated expansion of the universe. But this is just a placeholder. Dark energy is really just a term for we don't know what's going on. Others propose modifications to our understanding of gravity itself. Maybe the rules we use to describe gravitational attraction on cosmic scales need to be adjusted. The universe is proving to be a lot more complicated and fascinating than we ever imagined. The James Webb Telescope is just at the beginning of its mission, but it's already given us insights that will likely lead to major revisions in our theories about the cosmos. Rogue planets drifting in the dark, massive galaxies that shouldn't exist, black holes that seem impossibly large for their age, and an expansion rate that makes no sense. All of these discoveries are pushing scientists to rethink some of the most fundamental principles of astrophysics and cosmology. Beyond strange galaxies and black holes, there are planets that don't follow the rules. Rogue planets defy cosmic rules. These mysteries are interconnected. The formation of rogue planets might tell us something new about how stars and planetary systems evolve. The rapid formation of early galaxies could change our understanding of dark matter and the role it plays in galaxy evolution. And the unexpected size of black holes in the early universe could offer clues to how the universe itself was structured in those first formative moments after the Big Bang. Each discovery is like a piece of a much larger puzzle, and Just T is giving us a clearer picture, but also showing us just how much we're still missing. What we're learning is that our understanding of the universe is still very much in its infancy. There's a lot we don't know, and much of what we think we know might be wrong. The James Webb Telescope is a reminder that science is an ongoing process, one where every answer only leads to more questions. And that's what makes it exciting. It's a journey, and we're all along for the ride as we watch our understanding of the cosmos grow and evolve. For now, all we can do is keep looking up and keep asking questions. The universe has secrets to reveal, and with tools like JWST, we're getting better and better at uncovering them. Whether it's rogue planets drifting through the vastness of space, galaxies that formed far too quickly, or black holes that defy explanation, each discovery is a step closer to understanding the beautiful, complex, and sometimes bewildering place we call the universe. And as we push forward, we might just find that the real story of our cosmos is even stranger and more wonderful than we ever dreamed. The James Webb Space Telescope, often called Webb for short, isn't just a fancy gadget for looking at stars. It's a mega powerful telescope that's showing us things about the universe we didn't even know we could find out. Webb is like a secret spy tool, peeking into the chemistry of distant planets to tell us what they're made of. Using its infrared tech, Webb can analyze the light passing through the atmospheres of these faraway planets and pick out molecules, kind of like solving a cosmic puzzle. This process, called spectroscopy, has turned out to be way more interesting and confusing than anyone expected. Take, for example, WASP-39b, a gas giant hanging out about 700 light-years away. When Webb checked out this planet, it found sulfur dioxide in its atmosphere. Now, sulfur dioxide is not something you'd expect floating around in a gas giant. On Earth, we mostly get it from volcanic eruptions or when sunlight messes with chemicals in the sky. So why is it on WASP-39b, a planet where nothing's supposed to make sense like that? Turns out there's some sort of photochemical reaction happening out there, a mix of sunlight and weird alien gases that's keeping things interesting. It's the first time we've seen this kind of molecule outside of our solar system, and honestly, it's making scientists rethink what we thought we knew about planetary atmospheres. Sulfur dioxide is not the only surprise. Webb also picked up carbon dioxide in WASP-39b's atmosphere, another first. Carbon dioxide is a big deal when it comes to understanding the atmosphere of a planet because it helps explain a lot about how the planet formed and how it's evolving. Finding this gas on a planet so far away means we might be able to do the same with even more planets, opening up a whole new world of possibilities. Who knows what kind of strange and unexpected findings are waiting out there? And then there's K218b, a planet that's a little more Earth-like, orbiting in its star's habitable zone. This means it could, just maybe, support life. When Webb took a closer look at this planet, it found something that might be dimethyl sulfide. On Earth, dimethyl sulfide is mostly produced by living organisms, and this raises the fascinating possibility: could there be life on K218b? Scientists are still debating this. It's not certain whether Webb really detected it, or if it's just some unusual chemical process that we don't fully understand yet. But if it's really there, and even if it's not biological, it's still an incredible finding. It's showing us something entirely new about planetary chemistry, and that's exciting all on its own. Not everything Webb has found is about searching for life, though. Sometimes it's just about understanding what's out there in all its bizarre glory. Take HD 209,458b, for instance. This is an ultra-hot gas giant with temperatures over 1,000 degrees Celsius, definitely not a place anyone would want to visit. Webb detected water vapor, sodium, and even hydrogen molecules breaking apart and recombining in this extreme environment. It's a chemical circus, and it's pushing scientists to reconsider how chemistry operates under these extreme conditions. It's all about figuring out the chaos of these strange planets and their wild, fiery atmospheres. These discoveries are shaking up what we thought we knew about how planets form and change over time. For a long time, scientists believed that gas giants formed in the colder parts of star systems, far from the heat, where they could gather lots of gas and ice. Then, over time, they'd migrate closer to their stars. But now, with Webb finding all these reactive chemicals, it looks like these planets' atmospheres are far more affected by their stars than anyone had thought. It's like their chemistry is in a constant state of change, and that's making us rethink a lot of old ideas about how planets behave. Webb's work is also hugely important for astrobiology, the search for life beyond Earth. The telescope is sensitive enough to detect tiny amounts of gases like methane, water vapor, and carbon dioxide, all things scientists look for when they're trying to figure out if a planet could support life. But here's the tricky part. These molecules can be produced by both living organisms and non-living processes. Methane, for instance, could come from microbes, but it could also be the result of volcanic activity. So even if Webb spots something, there's still a ton of work to figure out what's actually creating it. After learning about rogue planets, Webb shows us how planets evolve in surprising ways. New clues in planetary evolution unveiled by JWST. One of the coolest things about Webb is that it doesn't just provide a snapshot of these planets' atmospheres. It also helps scientists see how those atmospheres change over time. Maybe a planet has seasons, or maybe there's volcanic activity happening. Or perhaps a star flare is causing temporary changes. By getting this dynamic view, scientists hope to discover new processes or phenomena that they wouldn't catch just by taking a single look. And this is all just the beginning. Webb has so much more planned. Next up on its list is studying smaller, rocky planets, the kind that might be a little more like Earth. These planets are way harder to study because they're so much smaller and their atmospheres don't give off as strong a signal. But these rocky planets are also our best bet for finding something that could actually be habitable. Just imagine if we found an atmosphere full of oxygen and nitrogen, like Earth's, around a rocky planet far out there in space. That would be groundbreaking. Every molecule Webb detects helps to fill in a piece of the bigger puzzle of how planets form, evolve, and interact with their stars. From scorching gas giants covered in sulfur dioxide to temperate super-Earths that might just have life, the universe keeps showing us how complex and varied it really is. For as long as people have looked up at the stars, we've wondered if we're alone. And now, thanks to Webb, we're closer than ever to figuring that out. Webb's discoveries remind us that space isn't just empty and vast, it's packed with surprises, just waiting to be found. Then there's the case of K218b. This planet is classified as a super-Earth, meaning it's bigger than Earth but smaller than the gas giants like Neptune. It's also located in the habitable zone of its star, which means that temperatures might be just right for liquid water to exist, one of the key ingredients for life as we know it. When Webb looked at K218b, it found hints of dimethyl sulfide, a molecule that, on Earth, is almost entirely produced by life, specifically by microorganisms in the oceans. This raises some tantalizing possibilities. Could there be oceans on K218b filled with some kind of alien microorganisms? In the case of HD 209,458b, the detection of water vapor and sodium, as well as hydrogen molecules splitting apart and recombining, shows that even in extremely hot environments, there is a lot of chemical activity happening. This kind of environment, with temperatures over 1,000 degrees Celsius, isn't exactly friendly to life, but it does offer a laboratory for studying how matter behaves under extreme conditions. The insights gained from HD 209,458b can be applied to other hot gas giants and can help us understand the diversity of planetary systems across the galaxy. One of the big questions in astronomy has always been about how planets form and migrate through their star systems. Gas giants like Jupiter and Saturn in our solar system are thought to have formed far from the Sun, where it was cold enough for ice to condense and form solid cores. Over time, they gathered up large amounts of hydrogen and helium gas, becoming the massive planets we see today. Some of these gas giants, like those Webb has been studying, migrate inward, ending up very close to their stars. This process, known as planetary migration, can have a huge impact on the structure of a star system and the formation of other planets within it. The presence of reactive molecules like sulfur dioxide in the atmospheres of these close-in gas giants suggests that the chemistry of these planets is heavily influenced by their proximity to their stars. Stellar radiation is likely driving many of the chemical reactions we see, and this has implications for how we understand the evolution of these planets. If stellar radiation can significantly alter a planet's atmosphere, it means that the conditions we observe today might be very different from what they were in the past. This makes the study of exoplanet atmospheres not just a matter of understanding what's there now, but also of piecing together the history of these distant worlds. The next big challenge for Webb is to look at smaller, rocky planets, the kind that might be more similar to Earth. These planets are harder to study because they're smaller and don't have thick atmospheres like gas giants, which makes detecting molecules much more difficult. But these rocky planets are also the most likely candidates for finding life. If Webb can detect gases like oxygen, nitrogen, or methane in the atmosphere of a rocky planet, it could be a sign that something interesting is happening there, maybe even something biological. Webb's ability to detect changes in planetary atmospheres over time is another powerful tool in the search for life. By observing how an atmosphere changes, scientists can learn about the processes happening on the planet's surface or in its atmosphere. For example, seasonal changes could indicate the presence of plant life, while volcanic eruptions could release gases that hint at geological activity. The more we can learn about the dynamics of these distant worlds, the better our chances of finding one that could support life. The discoveries Webb has made so far are just a small taste of what's to come. The telescope is set to observe many more planets, both gas giants and rocky worlds, in the coming years. Each new observation adds another piece to the puzzle of how planets form, evolve, and interact with their environments. From the scorching atmospheres of ultra-hot gas giants to the potentially life-friendly conditions of super-Earths, Webb is revealing a universe that is far more diverse and complex than we ever imagined. For centuries, humans have looked up at the night sky and wondered if we're alone. The James Webb Space Telescope is helping to answer that question, one molecule at a time. Its discoveries remind us that the universe is not just vast and empty, it's full of surprises, full of worlds that challenge our understanding, and full of the potential for life. The journey to understand our place in the cosmos is only just beginning. And thanks to Webb, we are taking the next steps toward answering some of the biggest questions we've ever asked. If rogue planets are breaking the rules of our universe, what else might we have misunderstood? Let us know your thoughts below, and don't forget to like and subscribe for more cosmic mysteries.